Hello and welcome to Physical Science Chapter 5. This is the chapter on wave motion and sound. In this first section, which is called Forces and Elastic Materials, we will learn about some of the properties of elastic materials that are similar to waves and use those to help us understand waves a little bit more, a little bit in more detail as we can try to picture this wave motion. So we start by looking at an elastic material like a spring. And it's called elastic because we can stretch a spring and the spring will revert back to its original position because of what's called a restoring force. So initially, the spring would be at rest at some position X, as you could see in the picture A. And then in B, we've stretched the spring just a little bit, a distance delta X away. And if we are to release that, the spring is going to be pulled back by that restoring force past its original position and get to the position like we see here in the picture D, a distance delta X away from its original resting position. And this pattern repeats itself as long as the spring doesn't lose its energy and eventually come to a rest. One of the words that's used to describe this kind of motion that is repeating itself is a periodic motion. And similarly, waves can be described by periodic motion. Every time we move up in our spring, we get to the highest point, the maximum, where the spring is compressed. And that point is called the crest or the peak, which is the top. And as it goes back down, as this spring relaxes and stretches out, we get to the sort of the bowl shape, which is a trough. So the pattern kind of looks like this. We start at a certain point, and then we get up to that point, the same amplitude away, and then the pattern repeats itself again. So this picture of a periodic motion is very similar to the periodic motion of waves. And there are certain things that we can find in our graph that helps us to understand the same characteristic of this type of periodic motion from an elastic material like a spring to that of waves. On what's labeled X, the vertical axis, you see it says A, 0, and minus A. This is the amplitude of the wave. That's how big or tall that wave gets. So it goes up to A above the origin, and it goes down to negative A below the origin. So it's the same height, but below and above that baseline. And then the pattern repeats itself. On what is the x-axis, we see the letter T. That's for the time. And then we have the uppercase T, which we have labeled here. And we'll talk about what that T is, which is really the period. So we'll talk a little bit more about what that period means as it pertains to wave motion. So like we said, waves can be described by periodic motion, which we looked at before. Here's this type of oscillation for those of you who might have seen what's called a sine wave. This is a typical sine wave or trig function wave. And so let's make some other notes on this type of motion. For one thing, each cycle or each oscillation or every time it repeats, we say that is one complete vibration or one complete cycle. So that means we start at A and we go up back until we get to A, and then the cycle repeats itself. Now, the time that it takes for this one cycle to complete itself is called the period, and that's what letter T is here in the picture. We get to the similar point again where the pattern repeats and we get a period. So a period can be, for example, from this second ball here, from the second spring, all the way up until we see that pattern repeats at the same point on the wave, and that's a period. A period could also be starting from the point A at the peak here, all the way until we get to the other point or the other peak. frequency is the number of oscillations we have in 1 second. So we can have more than one oscillations happening in a second if it's a wave that's moving really quickly, and that tells us how often the wave comes, and hence we have frequency. And this equation is the relationship between the period t and the frequency f. You see that they are inversely proportional to each other. The unit of time, or the unit period, is a measure of the time, and the unit of time that we normally use is seconds. And for our frequency, the unit of frequency we use is hertz. And you might have heard hertz before. If you want to tune into a radio station, for example, it's in megahertz. Mega is 10 to the 6, or 1 million. So when we're tuning in to 95.8 megahertz, it's 95.8 million hertz, or 95.8 million oscillations every second. Next, we'll actually start looking at some characteristics of waves.